Hello, learners. Welcome to our session today. I am instructor CPA Ringo Frederick, and we are looking at business data analytics. In today's session, I want us to look at application of regression analysis. And what we are going to do today is what was tested in BDA paper that was just concluded the other day. That is December 2022 exams for BDA. These are the questions that you ask under the practical paper. We had section 2 basically, question 23, question 22, question 23, question 24, and question 25. So 21, question 22, 23, 24, and 25. So all these questions, of course, we have looked at them already in various areas where they fall. So today's session, I want us to look at regression analysis, application of management accounting in, or rather application of BDA in management accounting. So this question, we are told that Fragment Company Limited produces and sells shovels. The company provides the following data for quantities of shovels produced and related production cost for the calendar year 2021. I'm given the month, quantity produced, and production cost. So in this question of ours, see what the examiner wanted us to do. The examiner wanted us to determine the variable cost per unit and total variable cost using regression analysis. Part B, we are asked to estimate total production cost in the following number of units, if the following number of units are produced, 100, 150, 200. So the catch was we should include the lower and upper boundaries at 95% confidence interval. That was the catch that we should be very familiar with. Now, we also told to prepare a chart plotting the predicted y versus the actual y from the regression function determined in A above, and we are supposed to interpret our answer. So even before I proceed to work out this question, recall Mwalimu did the concept of regression while we were introducing regression analysis in BDA, and it is in my channel. If you can check it out, these are what we did. If you go to our videos on my channel, you'll find that I had already worked out business data analytics regression analysis. So if you're doing this paper and you watch this video, you'll be in a good position, right? That I'll be having aspect of
199, 200. Here it is. The treasure is down.
How to interpret the data, and also how to make informed decisions when it comes to forecast, and also to establish. It means that we had already worked out this one. And by the way, you guys, if at all you watch this video, I know this question was very easy. And those students who are attending the classes of BDA in MDarasa, I know they're also they found that question quite easy, right? And by the way, before I forget, of course, whenever you're watching these videos of course, you can always tend to say thank you for Mwalimu by just doing what? You can come here, say thank you, you can give us any amount that you wish, and we'll always appreciate, guys, right? So back to what we are doing here. So here we are asked to work out regression. So in a solution, these are what you must always remember. Talk of solution. If we are talking of regression, basically we're looking at cost estimation. And anytime you're talking of cost estimation, one predictor equation must always tend to click at the back of our mind, right? The predictor equation, which is always in the form of y, is equal to A plus bx. I did this in our introductory video while we were introducing application of BDA in management accounting, where A basically, in this case, y first of all will give us our total cost. Y basically y is our total cost. Talk of x simply here, or A, basically A is our fixed costs. Talk of fixed cost here, fixed cost. We're having, of course, our B basically is variable cost per unit. This is basically variable cost per unit, variable cost per unit. Talk of X is simply our number of units. X is basically number of units. So these are what we had when we introduced the concept of forecasting in management accounting. This function is always very key. So back to our question, I'm asked to determine the variable cost per unit and total variable cost using regression analysis. So what Mwalimu is going to do, I'm going to take this bit here because that will be a point of reference all through. I could have used it directly there, but I'm having it here so that I'll be showing you guys some various concepts. Of course, you can increase this for visibility. We can do 130 for visibility, right? So once we have this in mind, this will be very easy. The first question that the examiner wants us to do, the examiner here basically wanted us to determine our variable cost. The examiner here wanted us to determine our variable cost, and of course, 6 marks, of course, you are given. So just remove that bit. So at this point, I'll be required to determine our variable cost per unit and the total variable cost using regression analysis. So the easiest way, we can always use our regression parameter or function in our Excel, which I believe all of us, you're familiar with that. So what you can do, we can come at this point, then we go to our data ribbon. In our data ribbon, we go to data analysis. From data analysis, we select, I'm having various components, we'll select regression. Then I do OK. So in this case, explaining these variables, basically, you'll find that I'd done this question several times, so you'll find that it appears like that. So in this case, my input Y range, our input Y range, at this point, it will be upon you always to identify what is your Y factor and X factor. If at all you can go back to the video that we introduced this, we say that X values will always be in terms of quantity or non-monetary many a times, or term it as what? Term it as X, or rather X, basically that is independent variable. X will always be independent variable. X will always be independent variable, whereas Y will always be dependent variable. So what is depending on which factor? At this point, you can clearly see that for me to arrive at production cost, I must be having what? The quantities. So therefore, quantities will be independent variable, whereas production cost will be dependent variable. So that is to say that dependent variable is Y, which ideally this is now what you're having. So basically production cost will be our Y. So I'm going to select our Y values. X values basically now are the independent variable, which basically is number of units, which is X. I'm going to select that. Our interval confidence level, many a times default exit is always 95%, and that is also in statistics. You'll find that many a times also our confidence level will always place it at 95%, right? Then output range basically is where I want my data to appear. It's where I want my data to appear. I can either have it on the same Excel workbook, or we can have it probably on a different workbook. On my case, I wish to have it on the same Excel workbook, And actually, because you had it down here, so let me just take this, our values, which we have them here, right? Because it's where we are doing our computation. That is, sorry. So I'm having Y here, and of course X here. So basically I want it to be on the same page. So in this case, my output range, I'm going to select that sheet, basically my results to appear at that point. Then in this point, I want my residuals, basically in the event that we are talking of residuals, basically it's like component of degree of freedoms per se at some point, and basically our values estimates, which I had explained them earlier on. line feet plots, I want also my graph to appear. If you want your graph to appear, and I think that question you are asked here, part C, prepare a chart plotting the predicted y versus the actual y from the regression function. What I need to do in our regression, in of course our dialog box here, is to click this line fit plot. This will also give us our graph. So it's as if I'll be answering question A and C at once, right? So I'll just do OK. Once I have all this data, I'll just do OK and see the magic. Hula! It will give us all the details here, including, of course, the graph. You see where the graph is, including the graph, right? Including this graph of ours. So I'm just going to put it down, including the graph. This is a beauty part with knowing Excel functions, right? You'll find that within no minutes you'll have cleared the part A and C respectively. So these are what you should be having. These are what you should be having. These are what you should be having. So of course I can decide. Basically, we can either increase this, where in this case, basically maybe if I was to talk on part C of the question, where we are asked, part C of the question, where we are asked to basically prepare the chart plotting the predicted y versus the actual y from the regression function determined above. These are now our plotting in terms of our y, which is actual y, and the orange, this is predicted y, and we are done with that bit. So alternatively, also here you'll find that there are these students who will kind of do it like this. In this case, basically before I go there, you'll find that I can determine our values here, where our values in this case, the concept of determining the variable cost per unit, variable cost per unit. I know you'd be like, now Mwalimu, on this data, where is our variable cost per unit? Our variable cost per unit is always the slope, right? Because this is B. Recall what we said here. Recall, B is the variable cost per unit, right? So basically this is our B. This is our B, variable cost per unit, which is our B. So I'll be having it to be B, and therefore we'll be having B to be what? X variable 1. You see this one here? This is what I'm going to take to be our variable cost per unit, whereas my fixed cost per unit, our fixed cost per unit here, fixed cost per unit, I should be having it to be our A value, which in this case, my fixed cost per unit, I'll be having it as our intercept, which basically is that much, right? So this is how we are supposed to determine our variables. That is, of course, B, A, and all our variables asked here. So I don't know why the examiner asked of total variable cost. We could have been asked of the fixed cost, but anyway, because you are asked, we can't assume, we need to work it out. So what I'm going to do, I want to copy this data of mine. I want to bring it down here so that it should fit well. Yeah, so it has picked all correct. So basically at this point, because you are asked to determine the variable cost per unit and the total variable cost, determining the total variable cost, that will be easy. What I'm going to have, in this case, I'm going to take our total variable costs, right? Total variable cost, which at this point I'll be having my total variable cost. Of course, it is in shillings. We have determined our variable cost per unit, and we're having the number of units. So I'll just be taking that times my number of units, that to give us that much. I'm going to log, because it will be constant all through, I'm going to log variable cost per unit, so that if I drag it down, my formula will be the same Alt equals sign enter to give us our total variable cost. In this case, this is what you are asked to determine. As simple as that, as simple as that, as simple as that. It's only that Mwalimu basically here was explaining that, so you've taken time, but basically this is what you are asked to do. So we determine our variable cost per unit, and we have also determined our total variable cost in this case of ours. What about if you are asked total cost? If we are asked the total cost, it will have been easy, because now my total cost will have been easy if we are asked. So we are not asked. That will be easy because I'll just be having my fixed cost here. I'll be having our fixed cost at this point. Fixed cost, right? Recall fixed cost, we have already determined our fixed costs. We have already determined our fixed costs here. We've already determined our fixed cost, which basically is this, right? Recall in our parameters what Mwalimu was explained, what Mwalimu had explained here. Intercept is our fixed cost, this is our variable cost per unit, right? So I'll just take it there. Then this one should be the same all through up to that point. Therefore, determining our total cost, I'll just be taking my total variable cost plus my fixed cost. Hula, I drag it down here. Great. That will give us, of course, our total cost. So you are not asked, so you are not asked, so you are not asked. So now, after we are done with that case, we'll find that the same concepts, these are what you are having here. What we've said, our variable cost per unit, which the examiner wanted us to determine, and this is what we've determined. We've gone ahead and also determined our fixed cost per unit. Basically, this is the data that you're having here, right? Now, at this point, you'll find that there are other ways that probably some of you could have used to determine the same variable cost. Other function that you can use to determine a variable cost, this is easy because I'll be using our slope function, because B is a slope, of course, of our linear, or rather of our graph. So basically, I can just do equal sign. I do slope, you see? Returns the slope of the linear regression line through the given data points. These are another way, right? I do tab. My known y's is basically the total cost. So I'll just be taking my total cost. My known x, basically these are the number of units. Then hula, you see, the same value that you're determining. What about fixed cost? That will be just simple because this is the intercept. So I just do intercept tab, known y's total, I should be having it at that point, comma, known x, I should be having it at that point, then hula, enter. As simple as that. I have my values. I have my values, which are the same. So at this point, you're allowed to select the one that you preferred, because all of them are regression. All of them are regression. All of them are regression. Yeah, so I think we are done with part C and part A of the question. Part C and part A of the question, we are done with it. And this is what you're having. We prepared our graph here, and the beauty part with regression formula, that is data analysis regression. You see, if at all you can compare our predicted Y, which is our total cost, compare that with what you've done here manually. You see, if you can compare the two, you'll find that they are exactly the same. If you can compare these two, you'll find that basically they are exactly the same. You see, yeah, they are exactly the same. They are exactly the same. They are exactly the same. Yeah, they are exactly the same. They are exactly the same. They are exactly the same. You see, they are exactly the same. So basically, once we have that in mind, let us proceed to the most interesting part of the question, which was part B of the question. This is the most interesting part of the question, right? we need to estimate the total production cost if the following units are produced. So part B of the question. So ideally, we are done with that part. We are done with part C of the question here. Now we are looking at part B of the question. We are looking at part B of the question. So part B of the question, the examiner wants us to, part B of the question. Can you allow Mwalimu to hide this bit? Because this one you're done with it, so it won't assist us much as we proceed. So I'm just going to hide. We're going to unhide it as we proceed. So we need to estimate the total production cost if the following number of units are produced. That is 100,000, 100,000, 150, and 200. So 100,000, 100,000 here, 150, and 2,000. So basically, these are what you're supposed to do to estimate, right? Estimating this by the fact that we know our linear function here will be, by the fact that we know our linear function at this point, we should be talking, of course, of our y total cost that we are supposed to determine should be equal to my 95 point, or rather our 3,977,635.78 plus our B 95.172x. Recall, this is our function, right? This is our linear function or predictor equation that we have determined. This is our predictor equation that we have determined. So let us determine if my x is now, if our x is 100,000. What will I do? I'll just be taking my total cost, which is there, plus variable cost per unit times the number of units at that point. I do enter. In this case, I'm going to lock that part, and I'm going to lock this part to give us the total of that much. Total production cost if the following number of units are produced. And these are our total production cost if we produce this number of units given the equation that we have formed. Okay? The most interesting part, which I want to bring it to your attention, this is what you are asked. We include lower and upper boundaries at 95% intervals. We include the lower and upper boundaries at 95% intervals. This is a beauty part of this question of ours, my good students, because at this point you must always recall what you did in your management accounting in terms of the standard error, in terms of the t-values. Talk about the aspect of the standard errors, confidence intervals, and all these elements that you did at your basic level, either at QA or when you're doing management accounting. So first, at this point, you can see I'm given my 5% confidence interval level. So predicted value, basically predicted value is at 95%. Predicted value, basically we have it at 95%, in 95% correct. So what is the chance that I'll not be correct? What is our alpha? Our alpha, of course, will be 1 minus, that is, of course, will be 1 minus 95%, right? So my predicted value percentage is 95%. Predicted value, or desired level of prediction. We can talk of this desired level of prediction. desired level of prediction. These are desired level of prediction. At this point, you need to achieve 95%. Desired level of prediction at this point is 95%, right? 95%. Desired level of prediction is 95%. And of course, there's a chance that I won't be correct, which basically it will give us 5%. It will give us 5%. So once we have that in mind, my good students, this is the next step that you're supposed to work it out. After we have our desired level of prediction and we've already determined our point prediction, so now you'll find that this will be very easy, because now what I'll be having is basically for me to determine, we are supposed to determine, of course, already, yes, we've determined our point prediction, which the examiner wanted us to determine, but we are also supposed to include the lower and upper boundaries at 95% confidence interval. So that will be easy, because at this point I'll just be having our prediction, talk about our prediction at level. These are prediction at level level of production, prediction at level of production, where in this case, prediction at level of production, my good students, we have it here at this point, italic. So prediction at level of production, see, these are the units that we had, right? These are the units that we had. Then our point prediction basically are the total cost point prediction. This is basically management accounting, okay? This is basically management accounting or QA, right? So it depends where you studied your QA. It's only that you're applying what we did theoretically, now practically. So point prediction, basically at this point we've already determined, and these are the values that we have determined them. At this level, this is what we'll be having, right? And this is what we have determined them. That is what we have determined. Then from there, at this point, at any given point, if at all I'll be having my upper boundaries and lower boundaries, I must always have these items. I must always determine our T value, because this will assist us in determining, of course, our margin of error, and hence our lower boundary and upper boundary. So we must be having our T value. We must be having our standard error of prediction, okay? So basically I can just take this to be standard error of prediction. I can have, of course, we must have margin of error. We must be having margin of error. We must also have our now lower boundary, what the examiner wanted us to have, lower boundary, and talk of our upper boundary. So lower boundary and upper boundary, lower boundary and upper boundary, lower boundary and upper boundary. Yeah, so these are what you should be having. Yeah, so these are what you should be having. So once we have this, of course, to make it neat, I'll just add my boundary here, my border, sorry. So once we have this case, my good student, the next question will be, how are we going to work out all this? You'll be like, Mwalimu, now what are all these items? These are items that we did at our basic level, right? So our T value, remember, you can check it in our T table, or you can use our formula. Better still, you can use what? You can use our Excel. So to use our Excel to determine our T value, basically recall our Ti in V. So I'll be having equal sign Ti in V, whereby basically you find that basically it returns the two tail inverse of the student's distribution, T distribution, right? So in this case, of course, I'm having our error, which at this point, chance that I will not achieve the desired results is 5%. right? So basically, sorry, I'm having TIV, tab, I haven't clicked tab. So probability that I'm not going to achieve the desired results is 5%. Degree of freedom is always, of course, our aspect of the number of data values minus our regression parameters, which ideally in this case, degree of freedom is basically our residual. You see, DF standing for degree of freedom. I know you might be asking, Mwalimu, why haven't you taken us through all this? Because I did this at our first, when we were introducing this bit, and it is in our application, phone application, or web application in our account, Mdarasa platform. So in this case, residual value basically is, that is a degree of freedom, which is 10. Then I'll just do enter. So these are what will give us our t-value. You see how easy it is, right? So having that, because it is common, I'm going to lock that, and I'm going to lock that, so that if I do it, if I scroll it down, it just be the same. Now, the most interesting part is our standard error of prediction, okay? So standard error of prediction, this is quite easy. Recall the formula of standard error of prediction, the y cap, right? Standard error of prediction, where at this point you must always be having standard error square root of 1 plus 1 of n plus x minus mean squared divided by standard deviation squared of n minus 1. This is a formula that we had at our basic level. So Mwalimu is going to have this formula of ours here. Let me share this formula here, so that we should be like, Mwalimu, now what are you saying? Mwalimu, now what are you saying? So these are our formula, right? The standard error of prediction, standard error of prediction formula, standard error of prediction, standard error of prediction formula, standard error of prediction, standard error of prediction, right? Basically, we normally tend to talk of the y cap. So that is to say, where basically S, this basically stands for standard error. This is standard error. 1 plus 1 of n, and n is basically the number of data values, plus x, the actual input, minus x, this is a mean, this is a average or mean squared. The s, this s basically stands for the standard deviation squared into number of data values minus n. So at this point, therefore, it will be upon us to determine these variables. I need to determine our mean, which is x bar. Mean, in this case, it will just be our arithmetic average of x. Arithmetic average, that will be easy. I just do equal sign average. I come at that point, of course, average of what? Average of x. So I'll come here and select this is our x. Then comma, that is of course average of x. So basically this is not in percentage per se, but value, right? So basically this will give us average of x. What about standard deviation of x? The beauty part with the Excel, when you hear standard deviation now, you'll be like, Mwalimu, will you remember the formula? This will be easy. Standard deviation of x. Now you'll be like, Mwalimu, will I really recall or remember the formula? So these are what we should be having. I should be having our standard deviation. So I'll just do equal sign SD TD standard deviation. That is the STDEV standard deviation. That is estimate standard deviation based on sample, ignores logical values and text in the sample. Remember, all these items are for standard deviation, but ours, you are specifically on this. I'll be explaining this one later on as we proceed. Yeah, so I do tab. I need standard deviation of values of x, which ideally is at this point here, right? Enter. So once I have standard deviation, remember this is not percentage but value. So once we have determined our standard deviation and mean, I can now come and put this formula of ours here, right? That will be easy. How are we going to work it out? I'm going to do, of course, that is a standard error, which we've computed here. So I'll just do equal sign, my standard error, which I've computed it at that point, square root SQ RT tab square root of what? Square root of 1 plus 1 divided by number of data values, which basically is our observation, 12 plus what? Plus into bracket my actual input, which basically here is 100,000, minus our mean, which is 202,500. This one is squared, so raised to power 2. I'm going to divide this one by what? Standard deviation squared. My standard deviation squared, standard deviation, which we had computed it, standard deviation squared, of course, times our n number of data values, which basically is that minus 1, right? So that is what you're having, making sure that our data is well presented. Therefore, I should be having this in bracket. This is just now normal bit of, we want to kind of have this formula exactly that bracket. Then this one also, I should have it in bracket because it has covered that bit. Then at this point, I should be having this also in bracket to close that, our denominator. I've closed our denominator. The first bit is our numerator, that's why we've closed it. Then the general closing bracket, because we started with bracket. So I just do enter. Ula, my standard error. Instead of us copying this formula all through, I'm going to lock the common concepts, or rather common values, which include my standard error is common. So I'll lock it. My number of data values is common, that will not change, so I'm going to lock it. Our x bar, which is mean, is going to be common, so I'm going to lock it. That is x bar, I'm going to lock it. Then we are also having standard deviation is common, I'm going to lock it. Number of values is common, I'm going to lock it. So that once I copy this formula downwards, you'll find that, hula, it will give us what we need. After we are done with that, of course, determining our margin of error. Margin of error, that will be simple because I'll just be taking now my t value, I multiply by our standard error of prediction. I scroll it down. Our lower boundary, that will be easy because I'll just be taking our point prediction, of course, minus our margin of error. I scroll down like that. Upper boundary, that will also be simple because I'll just be taking our point prediction. We add our margin of error, right? In that case, we add our margin of error. So this is what I'll be having here. See the magic, hula. So this is based on what the examiner also had asked us to do, where we are supposed to estimate the total production cost in the following number of units that are produced, which we have estimated. Then also we are also supposed to do what? To include the lower and upper boundaries at 95% confidence intervals, which basically these are our 95% confidence interval. These are basically our boundaries. These are basically our boundaries at 95% confidence interval. So this is what you are asked to do, and that is what will have earned you the 12 marks. I know those students who attended Darasa class right now, wherever they are very, very happy because these are what you did, and I guided you, maybe not deep, but at least we covered the main elements, which I know you guys were very, very happy on what you got in your papers. Yeah, so that is what you are required to do. Guys, remember that the classes for BDA are on Darasa at any given point whenever probably you need an assistance in BDA, not only for Kasneb but BDA as a course. You can always reach us out on the number 0708068851, and we'll always guide you accordingly. So these are what you are asked to do, and basically that is what we have computed. And at this point we have covered the other concepts here. The other questions, we cover them at their respective areas. So guys, we are done with that question. We've earned all our 20 marks, and now those who did the exams, you can review the video and see probably where you missed. So at that point, guys, thank you so much, and we can meet in the next class. Thank you.